Today's lesson is about evaluating logarithm expressions. For logarithm definition, for b greater than 0 and b not equals to 1, x greater than 0. Log base b of x equals to y means b to the yth power equals x. Logarithm and exponential function are inverse to each other. We use exponential to solve logarithm equation. We use logarithm to solve exponential equation. For logarithm function, b we call base, x we call argument, or sometimes we call this is a power. Domain for this logarithm function, argument must be greater than 0. Range, it will be all real numbers. For logarithm, we can change into exponential form, doing b to the yth power equals x. When base is omitted, we call this is a common log. Base is 10. So we got the 10 to the yth power equals x, like this. Ln means natural log. Base is e. That's why e to the yth power equals x. E is a special number, just like pi is an irrational number. It equals 2.71828 and keep going. Let's go to some examples. Write an equivalent exponential equation for given logarithm equation. For a, I will get the 10 to the second power equals 100. Base won't change. Therefore, we got 10 squared equals 100. For d, you will get the 10 to the 1/2 power equals square root of 10. 10 to the 1/2 power equals square root of 10. For g as girl, 2 to the negative second power equals 1/4. 2 to the negative second power equals 1/4. For second question, write an equivalent logarithm equation for given exponential equation. Remember, log base never change. Log base 2 of 4 equals 2. 7 squared equals 49. Log base 7 of 49 equals 2. For g, log base 10 of 0.01 equals -2. Since log base 10, that's common log, I can write down common log of 0.01 equals -2. From these three equations, you could see that log is an exponent. Remember, log is an exponent. We use log to solve exponent. Let's look at logarithm formula 1. While you're working on logarithm, normally we change into exponential form. Think about a to what power equals 1. We know a to the 0 power equals 1. Therefore, log base a of 1 equals 0. A to the first power equals a. Therefore, log base a of a equals 1. Common log base is 10. Therefore, 10 to the first power equals 10. So we got the 1 here. For natural log, base is e. So e to the first power equals e. Therefore, natural log of e equals 1. Since a to the negative first power equals 1 over a, therefore, this is a negative 1. This is negative 1 too, because 1 over a to the negative first power equals a. When you evaluate logarithm expressions, these 3 logarithm formula are very, very important, because a to the r's power equals a to the r's power. Therefore, we got log base a of a to the r's power equals r. This is a 10. Therefore, you will get the x. Base is e for natural log. Therefore, this is x. Because a n's power to the m over n's power equals a to the m's power. Therefore, this is a true. For inverse rule, you will get the a to the logarithm base a of r equals r. When the base is a simple number, like 7, 5, 3, 10, normally we use log base a of a to the r's power equals r to evaluate. For e, this is 7, I cannot do anything, but 1 over square root of 7, we know that it's 7 to the negative 1/2 power. Therefore, I will get the log base 7, 7 to the negative 1/2 power. Then 7 is gone. I will got negative 1 over 2. Because log base a of a equals 1. 1 times negative 1/2 equals 1 over 2. Let's go to second one. I need to change 25 square root of 5 into 5 to what power? We do know 25, I can write down 5 squared. Square root of 5, that's 5 1/2. We add exponents, 2 plus 1/2. You will get the 5 over 2. So this will be 5 over 2's power. Therefore, I will get the log base of 5. 5 is a 5 over second power equals 5 over 2. For G, we got 1 over square root of 27. We want to get the 3 to what power? Therefore, 1 over square root of 27, I can write down 3 to the third power. We know square root, this is a 2. Therefore, you will get 3 to the 3 over second power. 1 over means negative exponents. Therefore, I will get the log base 3. 3 to the negative 3 over second power. Then your answer will be negative 3 over 2. For D, fourth root 1000. You want to change into 10 to what power? Therefore, I got 10 to the third power, that's 1000. And I can write down 3 over fourth power. So we change this into log base 10 of 10 to the 3 over fourth power. We will get 3 over 4. For F, common log base is 10. So we got the log base 10 of 10 to the 1/3 power. Your answer will be 1/3. This still common log. So 100 over square root of 10, I can write down 10 squared over 10 to the 1/2 power. Division of power, we subtract the exponents. So we got the 2 minus 1/2. You will get 3/2. I will get the log base is 10. Then you got 10 to the 3/2 power. Then equals 3/2. For m, I can write down natural log base is e. E to the negative first power. Then you will get -1. For n, natural log base is e. E to the 1/3 power. Therefore, equals 1/3. For number 5, evaluate each log. When the base is a complicated number like 16, 1/4, 1/9, you got to use this formula. Equals m/n. Try to make your base and argument into common base power form. So we got log 16 and 8, we can do 2. 16 I can do 2 to the 4th power. 8 I can do 2 to the 3rd power. Therefore 3/4. That's the answer. For number 4, I can do log base. 1/4 I can write down 2 to the -2nd power. For the 32, I can write down 2 to the 5th power. So you get the 5/2 equals -5/2. For number 7, log, we change base and argument into base 3 exponential form. So we got 1/9, that is 3 to the -2nd power. 243, we will do the 2 to the 5th power. We got 5/2. You will get -5/2. When base is a complicated number like 16, 1/4, 1/9, using this formula. When your base is a easy number, then we use log base a of a to the r's power equals r. For formula 3, change of base rule. If you have log base b of a, you can change the base, then do the division. For log base 1/b of a, we want to change into log base b of a. So for the log base 1/b of a, I want to use this one to express. Therefore, I will change base as b. I will get the log base b of a. Log base b of 1/b. This one, because b to the -1st power equals 1/b, you will get the -1 log base b of a. Therefore, you will get negative log base b of a. For this one, you will get the same log base b of a. And log base b of a, it will be equals 1 over log base a of b. And for this formula, you will get log base a of c. Because you're using the change of base formula, you can write down log base a of b times log base a of b log base a of c. So you reduce, get the log base a of c. The backwards of change of base formula, when division of log, you will get the log base b of a. For a, I can write down log base 2 of 32. Log base 2 of 2 to the 5th power. Therefore, you get 5. For this question, I will get the log base 0.2 of 25. Remember, whenever you see the decimal, you got to change it into a fraction, that is 1 over 5. Therefore, I will get the log base 5 of -1. 5 squared, you get the 2 over -1 equals -2.